Hello and welcome back to this week's additional math series. And what we're going to do is we're going to start off by first solving the problems we left last week. Now, for each of these problems, what we're required to do is identify the vertex, state whether it's a maximum or minimum, and then we're supposed to find the maximum or minimum value and the range for each of the quadratics. I'm just going to put the quadratics and I'm just going to start working. So let's start with the first one. So the first quadratic here, number 1, is f of x is equal to x squared minus 4x plus 1. So I'm going to say, let's put this over here, and I'm going to say, given that f of x is equal to this, then the vertex form is, remember, I have to factor out if there's a factor in front of here, which there is none. So I'm just going to say that f of x is equal to x squared, half of this squared minus 4x plus half of that is negative 2 squared minus negative 2 squared, and then plus 1. Simplify this with the perfect square, and then we say here f of x is equal, open bracket, x minus 2 close bracket squared, and then we simplify this. So this is 4, minus 4 plus 1 would be minus 3. So this is minus 3. That's our vertex form. And we're supposed to determine whether it's a max or min. Okay, so since a is greater than 0, since a is equal to 1 in this case, 1 is understood over here, all right, then the function, well then f of x is a minimum quadratic curve, right? So we know whether or not it's a minimum or maximum quadratic curve. Now we have to find that minimum value and the range. So we're going to say the minimum point is, and it's negative h, so negative 2, negative of negative 2, which is just simply positive 2, and then h, which is negative, sorry, k, which is negative 3. So the minimum point is 2, negative 3. The minimum value is negative 3 when x equal to 2. Remember, we want the y value. This is the y value. When we say the minimum value, we're looking at the y value. So it's minus 3 when x is equal to 2. And the range of values is the set of y that are members of the set of real numbers such that y is greater than equal to 3. Negative 3, sorry. Right? That's the range of values that we have for this function. Let's go to another one now, number 2, which is given that f of x is equal to 2x squared plus 8x plus 5. Let's see if we can solve the rest. Then the vertex form is, and again, what we're doing is we're factoring out that 2 first. 2, let me just put that equal sign here. 2 into x squared plus 4x close bracket plus 5. Then f of x would be equal to 2 into x squared plus 4x plus 2 squared minus 2 squared, and then with plus 5 at the end. Simplifying this, we have f of x would be equal to 2 into x plus 2 squared. Then we have this 2 out here by this 2 over here. So 2 2s are 4, that's minus 4. Positive 2 by minus 4. Positive 2 by minus 4 is minus 8. So we have minus 8 plus 5. And we work that out. So f of x is equal to 2 into x plus 2 squared minus 3. And then we're knowing that the minimum point, sorry, not the minimum point. Yes, sorry, the minimum point. The minimum point is, and negative h, so it's negative 2, k, which is negative 3. So the minimum point is that the minimum value is negative 3 when x equal negative 2, and the range is all y values, well, y that belongs to the set of real numbers such that y is greater than equal to negative 3. Right? Remember, once it's a minimum, everything has to be greater than that value. Let's do the other one, last one, number 3. And we're given that f of x is equal to minus x squared plus 2x plus 3. We're going to solve that. Then the vertex form is, well, we can say for after x, and this is minus x squared minus 2x close bracket plus 3. Then we'll have f of x will be equal to minus x squared minus 2x. And then we're going to add negative 1 squared. And then we're going to subtract negative 1 squared. And then we're going to add 3 at the end here. We're going to use our perfect square, which is minus open bracket x minus 1 squared. And then we have minus 1 squared is just going to be 1. 1 by minus 1 out here is going to be minus 1. Then we have a minus 1 out in front, which is going to make it a positive 1. So we have positive 1 plus 3 over here. And then f of x would be equal to minus open bracket x minus 1 close bracket squared plus 4. And then we have, notice that it's a negative sign. So let me just say you can say since a is equal to, since a is less than 0, and a is equal to 1 in this case, negative 1 in this case, then the curve is, well, curve has a maximum point. Right, so the curve has a maximum point. Let's see. The maximum point, the maximum value of f of x is, and we can see that it is going to be 4 when x is equal to 1. All right, so negative of this value, which is positive 1. So the maximum value of the function is 4 when x is equal to 1, and the range is the set of y that are members of the set of real numbers such that y is less than equal to 4. And that's the answers. Now, I made a little error right here where I did not state whether it's a max or min, right? So this here is min since a is since a is greater than 0. So this is a equal to 2. That's why we're saying that. So this is why we're saying it's a minimum point. All right, so that's that for these sets of problems that I gave you. Let's go on now to today's lesson. And today what we're supposed to do is we're supposed to explore the different methods that you would use to solve quadratic equations. Now the good news is you're already halfway finished with this topic, because the methods of factorization and completing the square can both be used to solve quadratic equations. And what I will do is I will introduce two other methods, one of which you would use a formula, and the other which you'll use is a graphing software called Desmos. Now, I am saying that you're using a graphing software. You cannot use a graphing software in the exam. You have to graph the function for yourself if you wish to be able to figure out the roots. However, that is not going to be something that would be plausible for you because it just takes too much time. Me giving you the graphing software is so that you can actually visualize what is happening when we identify the roots or when we identify the solution of a quadratic equation. So we will use every method to solve the following quadratic equation. The quadratic equation that we'll be solving is x squared minus 4x minus 5 equal to 0. Let me just change the color of this to green. Change this to orange. All right. So the first method that we're going to look at or we're going to apply is called factorization. So let me just put that over here. First method is factorization. Now you already did factorization and you know how to factorize a quadratic equation. So if you're given, let me just write this in a different color. So if you're given x squared minus 4x minus 5 equal to 0 and you're required to solve it, the first thing we want to do is factorize it. Well, try to factorize it. So we're saying we're going to get minus 5, and what we're looking at is 1 times minus 5, which will multiply to give me minus 5, which will add to give me negative 4. So then the factors are x plus 1 and x minus 5. All right, so that's equal to 0. Now, at this point, we'll ask ourselves what two numbers, when multiplied, will give us 0. And the answer is that one of the numbers need to be 0 for you to be able to get 0. So that means, either x plus 1, which is this number over here, either this number is equal to 0, which would imply that x is equal to minus 1, or this number here, the x minus 5, is equal to 0, which would imply that x would be equal to 5. All right, so we basically obtained two values for which the function would be equal to 0. Either this number over here is 0 or this number over here is 0. If this number is over here is 0, then it means x is negative 1. If this number is over here is 0, it means x is 5. All right, So this method would be most efficient when you want the, well, sorry, this method would be most efficient when you have quadratic factors neatly factoring into integers or simple fractions. And it's quick and requires minimal amount of calculation. So once you reach there, you solved this entire problem already. All right, let's go on to the next method. Now, the next method that we would use is completing the square. All right, so in the second method, what we'll do is we'll apply completing the square. So given that x squared minus 4x minus 5 is equal to 0, then we can separate this and say x squared minus 4x minus 5. You know what? Let me just do the half one time. So plus of negative 2 squared minus of negative 2 squared minus 5 equal to 0. All right, and then we simplify that. We're going to get here x minus 2 squared, and then this here is 4 minus 5 minus 9 equal to 0. And then all we have to do now is make x the subject of the formula. So we're making x the subject of the equation, I should say. All right, now first off, you want to identify what is being done to your x. This is your x here. So we're seeing x is getting 2 subtracted from it first. All right, that's the first thing that's happening to it. We're seeing afterwards that the result is then being squared. And then we're seeing that that result minus 9 is going to be equal to 0. So what we have to do now is we have to reverse the order of the operations. So we have to plus 9, we have to square root instead of square, and we have to add 2. And once we do that series of operations in order, we'll be able to solve for x. So let's do them in order now. So I'm first going to add 9 to both sides. If I add 9 to both sides, I'm going to get x minus 2 squared is equal to 0, because the 9 that I add over here is going to cancel off with this 9, and then I add 9 over here. Oopsie, this is 9. Right? And you get 9 there. Next, we want to do the square root. So if I square root both sides, I'm going to get here x minus 2, and then I'm going to get plus or minus the square root of 9, which is equal to plus or minus 3. All right? Since what we can say is that negative 3 times negative 3 is equal to 9, and positive 3 times positive 3 is equal to 9, we will be able to say that we can get either positive 3 or negative 3 would be equal to 9 when we square it. Then we're going to add 2 for both sides. So we're going to have here x add 2 by itself. This here, when I add the 2, it's going to be 0. And then I'm going to have 2 plus 3 or 2 minus 3. And when I work this out, I can see that x would be equal to 5 or x would be equal to minus 1. And if we notice the answers that we had previously, minus 1, 5, those are the answers that we get here. Minus 1, 5. All right? So you can see that both methods give the same thing. Now, this is useful for quadratics that are difficult to factor. For example, when you don't have nice even integers and you're looking at it and you're seeing that you're having problems, this is what you would use when it is you're having that kind of issue. Now, the third method that you have is using a quadratic formula. And with this formula, all you have to do is substitute the values of a, b, and c into the formula, and you will get your answer. So quadratic equation. And a nice little test is to recognize that this quadratic equation just comes from taking this general form, ax squared plus bx plus c equal to 0, and just simply doing completion of the square on this here. If you use these general terms and you do completion of the square, you'd be able to get the quadratic formula for yourself. However, you're not required to learn that, right? But you can try it out just to see how you get it. The quadratic formula is as follows. For a, b, and c, x would be equivalent to minus b plus or minus the square root of b squared minus 4ac all over 2a. If you complete the square of this, you would get this. So again, all you have to do is use this formula and you would get your answers for x. Let's look at an example and see how we do this. So all you have to do is just simply substitute your values for a, b, and c into this equation and you'll get your values for x. Let's use our example and solve it. So now remember, our quadratic equation is x squared minus 4x minus 5 equals 0. That means a is equal to 1, b is equal to minus 4, and c is equal to minus 5. Therefore, x would be equal to minus of minus 4 plus or minus the square root of b squared, which is minus 4 squared, minus 4 into a into c, close bracket, divide by 2 into 1. We solve that and we'll get our answer. So we have here x equal to 4 plus or minus 4 4s are 16. Let me just write this in yellow so you can see what I'm talking about. 4 4s are 16 over here. Negative 4 by 1, negative 4, negative 4 by negative 5. This will be positive 20. So we have 16 plus 20, which is equal to 36. So that is plus or minus the root of 36. and then divide that by 2. Now, root of 36 is equal to 6. So then that means our answer is going to be that, which implies that x is equal to 6 plus 4, which is 10 over 2, or x would be equal to 4 minus 6, which is minus 2 over 2. And this here is 5, and this here is negative 1. Now, let's go and look at the last method, which is simply graphing the entire thing on one of the graphing calculators. All right, so this is the graphing calculator. Notice that it is desmos.com/calculator, and all we have to do is type in the function here. So x raised to the power of 2, then we say in minus 4x minus 5. Notice the graph was shifting around as we type it in. This is a good way to find out how each of these components makes the graph shaped the way that it does. All right, let's scroll out a little bit and notice that this is what our graph is supposed to look like. This here is our turning point, which we can get from our vertex form, which is 2, negative 9. Let's look back at our vertex form now. So on our vertex form here, we're seeing negative 2, which means 2, and then negative 9. So 2, negative 9. Then we have here, which is the y-intercept of the function. And that means that it's the point at which the curve is going to cut across the y-axis. Then we have these 2 points here, which is your negative 1, 0, and then your 5, 0. This here is called the roots of your equation. And it's also called the solutions, because notice that is 5, and notice that this is 1. All right, so it's basically, when you solve the equation, you're basically finding out the points at which the function is equal to 0. The function is equal to 0 along this horizontal x-axis right here. Notice it is at negative 1, and it is at 5. And this is the end of today's lesson. Now, remember, this quadratic formula is useful for every single quadratic. We're not going to be able to use your graphing calculator that I just showed you, but it's useful for when you're doing functions or doing quadratic equations that you use it so that you can see what the functions look like. All right. Again, this is useful for every single quadratic that you have. This is useful when it is that you don't have them factoring easily. This is useful for when you have them factoring into nice integers. All right. Now, let me just make one quick note here at the bottom. This is for the graphical method. So, graphical method. And that is the website that we're using for the graphing calculator. So it's, all right, so that is the link to the graphing calculator that you can use your graphical method to try and help you understand what is happening when you have these quadratic functions. We'll use them a little bit more when we go on to the point of sketching quadratic equations. Now, that's the end of this topic, this lesson, and I'm going to give you some problems for you to solve, and we'll solve them tomorrow. X squared plus 6x plus 8 equals 0. 2x squared minus 3x minus 2 equals 0. X squared minus 2x plus 1 equals 0. 3x squared plus x minus 4 equals 0. And then the last one, x squared plus 4x plus 5 equals 0. All right, so solve these problems. I'll solve it tomorrow, and we'll start with our next lesson tomorrow. And if you have any questions, if you have any comments, please let me know. If you see any errors, again, let me know. I can make mistakes. It's not that I'm invulnerable to mistakes. If you see them, or you have an issue, or something's not seeming right, just simply leave a message and I will get back to you. I'll see you tomorrow for the next lesson.